This cosmic event could light up the sky like never before. A star that refuses to die. Almost 3,000 light-years from our planet, a binary star system known as Coronae Borealis is about to put on a show that happens roughly once a century. The explosion this star emits is not a supernova, but it resembles one enough to become one of the most anticipated astronomical phenomena of the year. This event, known as a recurrent nova, occurs when one of the stars in the system, an extremely dense white dwarf, steals matter from its red giant companion until it reaches a pressure and temperature high enough to trigger a nuclear explosion on its surface. What's fascinating is that after this explosion, the star doesn't vanish. It simply dims during another long cycle of matter accumulation, as if the universe is giving it a second chance. This celestial dance has repeated with surprising regularity. The first time it was observed was in the year 1866, when amateur astronomer John Birmingham, walking under the night sky of Ireland, noticed a new star shining in the constellation of Coronae Borealis. Since then, astronomers have kept a close watch for every possible reappearance. The most recent outburst occurred in 1946, and scientists believe a new explosion is imminent, probably within the next few months. These types of events, although more frequent than a supernova, are rare enough to inspire awe every time they occur. At its brightest point, the Coronae Borealis system could match the luminosity of the most visible stars in the night sky, becoming noticeable even without telescopes. Its apparent magnitude will shift from 10 completely invisible to the naked eye to around 2 or 3, making it one of the most prominent stars for a few days. The mechanism that turns a dying star into a celestial spectacle. To understand why Coronae Borealis, nicknamed the blazing star, behaves this way, it's necessary to delve into the processes that govern the lives of binary stars. This system is composed of two celestial bodies orbiting one another, a white dwarf and a red giant. The former is the collapsed core of an old star similar to our Sun, a structure so dense that a teaspoon of its matter would weigh tons. The latter, by contrast, is in the final stage of its life, bloated and constantly losing mass. The gravity of the white dwarf is so intense that it slowly pulls matter from its companion, accumulating a superficial layer of hydrogen. Over time, that layer reaches extreme temperatures and pressures, triggering a thermonuclear reaction on the surface of the white dwarf. This reaction does not destroy the star, but it releases an enormous amount of energy, enough for the system to increase its brightness up to 1,500 times within a matter of hours. This is what is known as a classical nova, a repeatable outburst, as long as the system manages to survive itself. What's most surprising is that, unlike supernovae, classical novae do not involve the definitive death of the star. After each explosion, the white dwarf remains almost intact, ready to begin the process of hydrogen accumulation all over again. It's a kind of stellar resurrection, a continuous cycle of buildup, explosion, and rebirth. This behavior has turned Coronae Borealis into a natural laboratory for studying the final stages of stellar evolution and the dynamics of binary stars. During the days when the explosion is visible, thousands of astronomers and skywatchers around the world will point their telescopes toward the Coronae Borealis constellation. Even those without specialized equipment will be able to spot this bright point appearing where there was nothing before. It will be a rare opportunity to witness, with your own eyes, the power of stellar physics in action. Why this explosion is a unique opportunity for science. Every nova visible from Earth represents an invaluable opportunity for modern astronomy. Coronae Borealis is no exception. While in the past humanity was limited to observing these phenomena with the naked eye and recording them in rudimentary ways, today astronomers have access to space telescopes, advanced spectroscopes, and tracking systems that will allow them to study this explosion with unprecedented detail. This includes the ability to analyze the chemical composition of the expelled material, its expansion speed, and the dynamics of the interaction between the white dwarf and its companion. When the nova occurs, instruments will be ready to capture the first signs of the outburst. The light emitted by the explosion will travel 3,000 light-years before reaching us. This time delay means that, in a sense, we will be witnessing an event that occurred long before human civilizations, as we know them, even existed. The information contained in that light may reveal details about the temperature of the stellar plasma, the presence of elements such as carbon, oxygen, or iron, and the energy distribution across different wavelengths. In addition, observatories will be able to measure emissions in X-rays, ultraviolet, and infrared radiation. This will help to better understand how magnetic fields behave during these explosions and how they interact with the interstellar medium. The study of novae is also key to improving our understanding of more violent events, such as Type Ia supernovae, which do completely destroy the white dwarf and are essential for measuring cosmic distances in the universe. The nova of the blaze star, as it is also known, will serve to test astrophysical models about mass transfer, thermonuclear detonation, and the evolution of binary systems. Scientists hope this event will provide data that help solve an old mystery: when and why a white dwarf transitions from the nova cycle to the supernova stage. Understanding this leap could shed light on the history of many galaxies, including our own. The scientific community is preparing with great enthusiasm, and you can be part of this unique event too. All you have to do is look up at the sky at the right moment and perhaps witness one of the most breathtaking spectacles in the cosmos. How and when you can see the nova with your own eyes. Witnessing a nova with the naked eye is not something that happens every day. For most people, this phenomenon is as rare as seeing a bright comet or a total solar eclipse. That's why the outburst of Coronae Borealis represents a historic opportunity. And the best part is, you don't need to be an astronomer or own a telescope to enjoy the show. All it takes is looking up at the sky at the right moment. Although the exact date of the explosion cannot be predicted, astronomers have studied the activity patterns of this binary star for decades. The last time a nova occurred in this system was in the year 1946. Nearly 80 years have passed since then, and everything indicates that the new eruption is about to happen. Experts agree that it will likely take place during the second half of 2024, probably sometime between July and September. When it happens, the blaze star will suddenly increase in brightness. It will go from a magnitude of 10, invisible to the human eye, to a magnitude between 2 and 3, placing it among the brightest stars in the night sky. For comparison, it will shine similarly to Polaris, the North Star. This change will be so dramatic that it may appear as if a new star has been born in the sky, and indeed, that's what many ancient cultures believed when witnessing similar phenomena. To find it, you'll need to locate the Coronae Borealis constellation, a semicircle of stars in the northern sky, between the constellations Hercules and Boötes. From hemispheres with clear skies and little light pollution, it will be visible without any technical aid. However, if you do have binoculars or a basic telescope, you'll be able to notice details in the color and the surroundings of the exploding star. The visibility won't last long. Within days, the nova will slowly fade until it disappears once again. That's why it's important to stay alert to astronomical announcements. Various observatories and science media will report in real time when the nova begins. If you want to experience a unique astronomical moment, all you'll need is some patience, a clear sky, and to look where the universe decides to ignite a new, fleeting yet unforgettable light. If you enjoyed this journey through the mysteries of the cosmos, subscribe to Midblown Space and join us for every new adventure the stars have in store.